So, how did you get on? This is a puzzle we like to have out on our Maths in the City and our big maths, outdoor maths events, alongside the Towers of Hanoi. But unlike the Towers of Hanoi, this one you just get stuck. And if you go wrong, you get stuck and you have to start again. Towers of Hanoi and other things, you can just keep going and you might eventually get there. You don't have to start again. So let's take a look. How did you get on? Well, here is a typical way somebody does it. And you can already see that they're stuck and it can go one more, but you only get that one home. So at this stage, you will have seen that at this stage, you will have seen that they're stuck. So let's start again and see. This is the classic way that almost everyone starts this puzzle. So we go forward, we jump over, we go forward again because we like going forward, and we jump over here. Now, at this point here, we should be able to notice that there's no way we can get these out if there's two of these going in this direction. So we're stuck. So we might have learned that if there's two coins of the same denomination together, you're going to be stuck. There's no way another coin can get over going in that direction. So no matter what we do here, these are stuck. So let's start again, and we're trying to avoid that. So if we have two together, apart from at the start, if we have two together over here, we will be stuck. So we want to aim then. So now we have a new puzzle. So if the puzzle at the start was try and arrange these coins so that it's uh, A, B, A, B, A, B, so no two of the same set together, that's an entirely easier puzzle for people to do. So I want to alternate these coins. So now, next one, I want to keep them, I want to alternate them. So I need to move this one in. So then I can move this one over, and this one over, and this one forward. So now they're alternated. So if you want to try that and then see can you solve it, if you haven't solved it already, try this, stop the video, have a go, and see can you get to this point and then get the rest of the way on your own. So now I'm going to just finish it off. You were invited to get to this position. So at this, we're moving these in this direction. So that is one home. That is moves there, that moves there, and then we've one home at this end. Now this one can move here. Now we don't want to move that one up because we'll have two of the same set together and we'll be stuck. So we want to move this over here. And now we've another home there. This can jump here. And there we are. That is the six frogs problem completed. So what can we learn from this in terms of problem solving? So we've seen a number of approaches. One is just have a go, get stuck in. It's great if you can build a physical model of a puzzle because you can manipulate it much easier. Now, so we have a go, then we get a bit more sophisticated. We start looking to see where did we go wrong? How do we know when we're wrong? Can we back up and try something else? Or the other thing was we might have spotted the pattern when we have two together. We don't want to have two of the same set together, so we need to alternate them. And that's much easier to aim for. So we managed to alternate them, and then it was an easier matter to bring them all home. You might have tried simplifying it as well, and you might have seen, you might have learned something from that that would help you. So now that you know that, do you think you could do the 8 frog problem? You probably can, because you've learned this strategy. Now it's interesting just to look back on it, why people find it so difficult. Because the vast majority of people, I reckon 8 or 9 out of 10, when I'm supervising this, they go like that, they go like that, and the first one they move forward again, where the move has to be this one. So that is the secret of the six frogs problem. Now, as a challenge for you, can you count how many steps this takes? And then maybe start with the four frogs and see how many uh, moves that takes. Four frogs on 5 lily pads. Then we have our 6 frogs on 7 lily pads. And then we're going to go for our 8 frogs on 9 lily pads. And can you find a pattern in how long it takes, how many moves it takes for each one? If you can, then you're well on your way to being a mathematician and an expert problem solver.